Partial fraction decomposition. What this lesson is, it's incredibly intimidating, the name of it, and it does get a little bit lengthy at times, but we're going to look at some basic partial fraction decomposition problems here. And what partial fraction decomposition does, in my own words, is it unadds rational exponents. That's not supposed to say exponents. Hang on a sec. There. Rational expressions, not rational exponents. So it's used to unadd rational expressions. And what I mean, if you can remember way back to Algebra 1, you learn how to add rational expressions, which means you started with your original problem being, where's my magic pen? Here we go. You would start off with this problem right there. And you were told you had to add those two together. So you'd get a common denominator. You'd multiply the one on the left by x minus 3 on top and bottom, the one on the right by x plus 1 on top and bottom, and you would add those two fractions together to create one fraction. Well, with partial fraction decomposition, we go in the exact opposite direction. We unadd the rational expression. And so what we'll do in partial fractions is we will start with a fraction like this, where it's already one fraction, and then what we're going to do is use a whole bunch of steps to figure out that the original two fractions were 1 over x plus 1 and 2 over x minus 3. So that's what the goal is, to find out what the original two fractions were, or 3 or 4, however many we started with, that add to give you 3x minus 1 over that. So let's try an example or 3. Okay, first one. This is actually the one we just did, or the one that was on that last page. If my final answer is 3x minus 1 over x plus 1 x minus 3, then I know that I started with something over x plus 1 plus something over x minus 3. Those are the two fractions I started with, and it's based on whatever the denominator is. The factor's in the denominator, so we split it into something over x plus 1, something over x minus 3. What I don't know is what's in the numerator. So I have something on top of x plus 1, which I'll use A, and something on top of, that was supposed to be green. Why wasn't that green? And something on top of x minus 3, which will be B. B, where is it? There we go. Why isn't it green? Geez, hang on a sec. There, finally. Okay, so I set up my partial fraction decomposition like this. Then the next step we're going to do, once we set it up, a over x plus 1, b over x minus 3, then I take every single fraction in the whole equation, on the right side and on the left side, and I'm going to multiply every fraction by the overall common denominator, which will be this denominator right here. We're going to multiply everything by that denominator, or that expression. So I'm going to multiply by x plus 1, x minus 3 on this one, x plus 1, x minus 3 on this one, and x plus 1, x minus 3 on this one. And what's going to end up happening is we'll get a lot of canceling. For this one over here, this very first fraction, x plus 1's cancel. There's 1 on top and bottom, and x minus 3's cancel, leaving me with only 3x minus 1. Then on the right side, for this fraction, x plus 1's cancel, leaving me with a and an x minus 3. And then we have b, and on this one, the x minus 3 cancels, so it'll be b times, and I have the x plus 1 remaining. Good, good? All right, so at this point, there's two different ways you can continue solving. The first way I'm going to show you will work for every single partial fractions problem. And what we're going to do, so what we'll do here is we're going to distribute the a and the b on the right side of the equation. So I have 3x minus 1 equals, and then that would be ax minus 3a plus bx plus b. And then I'm going to group my like terms. Now, like terms are really hard to see here, but when I say like terms, that means I have an x term here and an x term here. So I'm going to put those two together. I'm going to put ax plus bx together. And then terms without an x, I have a negative 3 and a positive b, or negative 3a. So I'll put minus 3a and a positive b together. The right side is still 3x minus 1. And then out of this first set, I can factor in x. So I'll have x times b minus a, or I'm sorry, a plus b. And then the green one, there's nothing you can factor out. We'll just leave that as it is. You only need to factor out x's. So that gives me 3x minus 1 equals all of this stuff. And then I'm going to go really crazy one last time and make this 3x minus 1 times a plus b. And I'm just going to move the x to the other side. Instead of x, I said times. 3x minus 1 equals, and instead of x times a plus b, I'm going to say a plus b times x. I'm just going to move that x to the other side, and 3a plus b. Now what we do is we look at the left and the right sides of the equation, and on the left side, my coefficient of x is 3. Well, if these two sides are equal, then the coefficient of x is 3 on the left side. The stuff in front of my x on the right side also has to be 3. So I'm going to say, I know that a plus b has to equal 3. And then my stuff without an x, on the left side I have a negative 1 for a constant. On the right side I've got minus 3a plus b. So I know that negative 3a plus b is equal to negative 1. And what I've done here is I've created a system of equations, and I can solve this system of equations for either a or b. Actually, I need to solve for both of them. And I like to use elimination. So I'm looking at my a's. They already have a different sign. One's negative and one's positive. If I multiply this equation right here by 3, then that would give me 3a plus 3b is equal to 3 times 3 is 9. And now I'll add these two equations together. The a's cancel. B plus 3b is 4b. Negative 1 plus 9 is 8. And I know that b is equal to 2. So now I've solved for b. I know what number is going to be on top of the x minus 3, which was b. Once I know b, then I could find a. Since I know that a plus b is equal to 3, then I can take this b equals 2, and I can say that a plus, instead of b, a plus 2 is equal to 3. Subtract 1, and you get a equals 1. So now I've solved for a and b, and what I do to kill this problem dead, my very last step, is I'm going to write these two fractions, a over x plus 1, except now I know that a is 1. B over x minus 3, except I know that b is 2. And that is your answer for the partial fraction decomposition of 3x minus 1 over x plus 1, x minus 3. And if we go back to that last page, I told you this was the same problem that we just had, you'll see that 3x minus 1 over that is 1 over x plus 1 and 2 over x minus 3. That's exactly what I ended up with right here. Now I told you that there were two ways to solve this, and this way works, and the start from this point down, that approach works for every single partial fractions problem you'll encounter. But there is a shortcut that can cut out about 80% of all of that work. And what you do, once you get to this point where you got 3x minus 1 equals a, x minus 3, b, x plus 1, what we'll do is we're going to go, oh geez, what's happening there? Give myself a little bit more room. Whatever a and b are, which we know that it's 1 and 2. I can't remember what it was. Was it 1 and 2? Yeah. We know they're 1 and 2, but whatever a and b are, they work for every single value of x you could possibly plug in. So what I'm going to do is I'm going to look at my a, and a is being multiplied by x minus 3. Well, if you think about x minus 3, if you set that equal to 0, you'll get x equals 3. So what I'm going to do is I'm going to plug x equals 3 into this whole equation. So I'd have 3 times 3, which is 9, minus 1 is equal to a times 3 minus 3, which is 0, plus b times 3 plus 1, which is 4. And now I solve that equation. A times 0 goes away. 9 minus 1 is 8, equals b times 4. And I know that b is going to equal 2. So I just solved for b. It's a lot easier that way. Then I need to plug in something else because I haven't solved for a. So I need to find a way to cancel my b. And I'm going to do that by finding out what makes x plus 1 equal to 0. Well, you subtract 1, you get negative 1. So I'm going to plug in negative 1. And if I do that, 3 times negative 1 is negative 3 minus 1 equals a times negative 1 minus 3 is negative 4 plus b times negative 1 plus 1 is 0. Negative 3 minus 1 equals negative 4a. And divide by negative 4 and you get a to be 1. And so in that little bitty bit of work, I was able to solve for a and b the same answers that I got when I did all of this work the first time I solved it. They both will work. But this way, if you can use this technique, I would use it. So I would finish it up by saying 1 over x plus 1, because that's what a was, over x plus 1, and then b, which is 2 over x minus 3. And so that would be your final answer. You good? All right, I think there are 2 more problems I wanted to do. Okay, here's one, x plus 19 over that. This one, my denominator is not factored. So my very first step is actually going to be to factor the denominator. And that's going to factor to x plus 5, x minus 2. Then, if I know what my factors are in the denominator, I know that I started with something over x plus 5 plus something over x minus 2. What I don't know is what that something is. I need to solve for the numbers over x plus 5 and x minus 2. Good? So you factor, set up one fraction for the first factor, another fraction for the second factor. Then I will multiply everything, every single fraction. I'm going to multiply by x plus 5, x minus 2. X plus 5, x minus 2. And for the sake of time, I'm going to copy and paste that. X plus 5, x minus 2. And x plus 5, x minus 2. Waha! Okay, so looking at the first one, x plus 5, x minus 2 cancels, leaving you with only x plus 19 equals. Then this one, x plus 5's cancel, leaving you with a times x minus 2 plus my last fraction, x minus 2 cancels, and you're left with b times x plus 5. Okay, now I'll look at my factors, and I look at this equation, and I wonder, what can I plug in for x that's going to make this 0? And I think, well, if I can plug in 2, 2 minus 2 is 0. So that's what I'm going to plug in first. Let's plug in 2. 2 plus 19 is 21. A times 2 minus 2 is 0. B times 2 plus 5 is 7. So 21 equals b times 7, or 7b. And we know that b is equal to 3. Okay, so now I have b. Well, now I've got to find out how to solve for a, which means I need to get rid of my b term over here. So x plus 5, if I plug in negative 5, I will get a 0. So let's plug in negative 5. If I plug in negative 5 plus 19 is 14. A times negative 5 minus 2 is negative 7. Plus b times negative 5 plus 5 is 0. So 14 equals negative 7a. The b term cancels because we're multiplying by 0. Same thing up here. A times 0 canceled. And we know that a is going to be negative 2. And we have done all the hard work now. But don't get lazy. This is not the final answer. Your final answer is what you get when you plug your numbers back in. A is negative 2. And I put a over x plus 5. B is over x minus 2. And we know that b is 3. So that is your answer for this problem. Good, good? Good, good? Good, good? And then one last problem. Bell's probably going to ring here in a minute to start class, so I may have to pause and come back a couple of hours later. Let's see. This one has an x cubed, which we're still going to use the same approach, but since the degree of my denominator is 3, that number actually tells you how many letters you're going to solve for. So for this problem, we're going to need an a, b, and a c. And when you factor this out, you'll see why. The first thing I'm going to do is factor out an x, which will leave me with x squared minus 9. And then I will factor out that difference of squares, which will give me x plus 3, x minus 3. So what I have here is 3 factors in the denominator. So when I set up the partial fraction decomposition, it's 1 over x, x plus 3, x minus 3. And I'm going to set that up as the something over x, because that's my first factor, plus something over x plus 3, plus something over x minus 3. And then we will multiply everything by the common denominator, which my common denominator is x, x plus 3, x minus 3. And let me copy and paste all that in. All right, that got like insanely jumbled up, and that's going to happen sometimes. But it's this fraction times all of that, then this fraction times x, x plus 3, x minus 3, this fraction times that, and then we start canceling. My first fraction, everything's always going to cancel, and I'm only left with a 1. On my second one, the x cancels, leaving you with a, x plus 3, x minus 3. My second one, the x plus 3 cancels, leaving a, x, x minus 3, or b, times x minus 3. And then my last one, the x minus 3 cancels, leaving you with c times x plus 3. And now one by one, I'm going to start plugging in whatever gives me a 0. And there's the bell, so I'm going to pause and come back and finish this later. Okay, so the values of x, the first one I'm going to plug in, and I'll look at my different factors here, and I see this x plus 3. I know that negative 3 is going to make that 0. So I'm going to start by plugging in x equals negative 3. If I do that, let's see, the left side is 1, and that's not going to change, equals. Okay, so I have a times, and negative 3 plus 3 is 0. Negative 3 minus 3 is negative 6 plus, and then b times negative 3 for x. And negative 3 minus 3 is negative 6 plus c times negative 3 for x. And negative 3 plus 3 is 0. And then we'll clean that up, and we get 1 is equal to a times 0. That just wipes out altogether. And so does the c times 3 times 0, or negative 3 times 0. And we have b is 18, negative 3 times negative 6 is 18b. And we end up getting b equals 1 over 18, which is not what I was expecting. So I'm going to pause this and double check my work real quick. Yep, that's right. It's just ugly. Okay, so we get b equals 1 over 18. Now I need to go back and see what else I can plug in. I've already plugged in 3, or negative 3, but I notice I have an x minus 3 here. If I plug in positive 3 for that, that's going to give me a different 0. So now I'm going to plug in x equals 3. And so I'll go back up here. I have 1 equals a times 3 plus 3 is 6. 3 minus 3 is 0. Plus b times 3 for x, and 3 minus 3 is 0, minus c times 3 for x, and 3 plus 3 is 6. And again, we get stuff to cancel. 6 times 0 and 3 times 0, all of that cancels, and we're left with 1 equals negative 18c. When you divide by negative 18, you get c to be negative 1 over 18. Okay, so I solved for C. Go circle my B answer so I don't lose it. And then last, I need to find a way to solve for A, which means I need to cancel one more thing. Let's see, I've already plugged in negative 3 and 3. Let's see, right here I have just an x. If I plug in 0 for x, that's going to give me a 0 inside that parentheses. So let's plug in 0. It's going to give me 1 equals a times 0 plus 3 and 0 minus 3 plus b times 0, 0 minus 3 is negative 3. c times 0 for x and 0 plus 3. And my b and c terms cancel this time. So now b times 0 times 3 cancels, c times 0 times 3 cancels. 3 times negative 3 is negative 9, a, and we get a to be negative 1/9. Okay, now here's where you're going to be tempted to quit because we've done all the hard work. We finally solved for a, b, and c, but that is not the final answer. Our final answer, we go back and look at how we originally split up the fraction, and I see that I had a over an x. So my a was negative 1/9, and I'm just going to leave this as an ugly fraction. 1/9 is a, and it was over x. Plus b, which is 1/18, and 1/18 is going to go over x plus 3. And then finally c, which is negative 1/18, and c was over x minus 3. And there is our final answer for this one. Kind of ugly, but that's what it is. And yeah, so there, partial fractions.